All right, Spencer, the question was, using a definition of a derivative in terms of a limit, evaluate this at that. So I have to use the limit definition, not my tricks and rules like the power rules, okay? So the limit definition says, find the limit of f of x plus h minus f of x over h as the h goes to 0. That's the limit definition that we learned. Well, that means I need to find f of x plus h. So if I plug in x plus h into that, that would give me this. So that's the first part. And then the f of x is plug an x in there. Well, that's this. So I'm going to subtract that. And I'm going to divide that whole thing by h, and I'm going to take the limit as h goes to 0. Now the problem is when I plug a 0 there and a 0 there, this and this all cancels, and it's over h. So I get 0 over 0. 0 over 0 means there's a hole, so I know there's a limit, but I got to go find it. So what I'm going to do is FOIL it all out, cancel everything, and I bet there's a common factor of h that I can cancel like I normally do with holes, and then I'd be able to do it, right? So right here, if I do this, I'm going to get 4. I'm going to FOIL that and multiply the 4 in. I'm going to distribute that, add a 5, distribute that, divide the whole thing by h, and you can see that cancels, that cancels, that cancels, and everything left has an h in it. So then I'm going to save a step, but if I'm rewriting this, I can cancel 1h with 1h there, 1h there, and 1h there. That's canceling out the whole. So that leaves me 8x plus 4h minus 3, 8x plus 4h minus 3. And I can now take the limit of this and not get 0 over 0. So you can see when I take the limit now, I get 8x plus 0 minus 3. So this equation is my definition of a derivative of that function, which you kind of already knew because if you did your power, you get at x minus 3. But the question is, what is the derivative when x is 2? So I'm going to take the derivative at 2, and I get 16 minus 3, which is 13. And that would be the definition of a derivative in terms of limits using the limit definition, which I would never want to do, but that's the way all of those little rules you had were proved, and that is another way to do it. I know your big question is, will I ask you that on the test? Probably not, but I would do this. I would give you this, maybe. And I might even have the 2 plugged in there. And say, evaluate the limit. And then your job would be to look at this and go, well, I could put 0 in, and if you do that, you get 0 over 0. So you could then do L'Hopital's rule and get 8, 2 plus h to the first, times the derivative of that, which is 1, minus, I would probably distribute this out, but you could say minus 1 times 3 is, I tell you what, I would distribute it out. It'd be a lot easier on you. And then the derivative of that's negative 3. Derivative of 5 is nothing. And this is a constant. The derivative of the constant is nothing. I'm sorry, and then the derivative of h is 1. And then redo the limit, and you get 8 times 2 is 16. 16 minus 3 is 13. So that's what I would do. And no, I won't make you do a really ugly one like I initially did, but that's, to answer your question, that's what number 39 was asking.